So, like I said, this will take us a few days to go through just because we have so many rules about derivatives. We have um, a lot of functions that we've worked with, natural logs, e to the x, all of our trigonometrics, square root. We have a lot of functions, okay? So we're going to take 3 days to go through this section just so we can look at all different types of examples of functions that we're dealing with, okay? So, I froze it. Okay. Okay. So we know that if we take the chain rule of a composition, okay, if we take the derivative of a composition, we have to use the chain rule, right? So if we take this derivative, then we have to take the derivative of the outside times the derivative of the inside, right?
Yeah.
So going backwards, if we have the antiderivative of the chain rule, we should get back to that composition, right? Okay. So this backwards chain rule is what we're going to call U substitution, right? You'll notice that this isn't, it doesn't look nice and pretty like our other rules. Each substitution problem is going to look a little bit different, okay? But today we're going to get the basics down and get some practice, okay? The only time we can use substitution is when we have the composition of a function inside of a function times another function, okay? So you'll notice up here, we have the composition times something else. That has to be the case for U substitution to even be an option. And you'll see why when we get to the examples. But if you see that you have the composition, somebody give me an example of a composition. 2x the quantity squared would be a composition. Cosine of
Cosine of
2x.
Cosine of sine of cosine of sine of cosine of sine.
Okay, that would be a very intense composition, but yes. Okay, so a composition, a function inside of another function. X squared plus 3 the quantity cubed. Okay, so we have to have a composition, but we also have to have multiplied by something else for it to work. Okay. The substitution that we're going to do is we're going to let U be an inner function. Okay, so whatever's inside of the function, that is what we're going to look at for U. Hold on. There's a way for me to have 2 pages on here at once.
Magic pen. Crayon.
Okay. So this is going to be the method that we're going to use, and I have an example. So what we're going to do is we're going to write down our steps as we do this. Does that make sense? Okay.
I really chose it. You just chose it. Where have you chosen?
Okay. So go ahead and write down the problem. I'll make it a little bit bigger since we're doing this style. Okay, so the first thing we're going to do is choose a U. And remember when we use substitution, my suggestion was it was the inside of the composition. So what's the inside of a composition here? Okay, so x squared plus 1 is inside of something to the 50th power. Okay, first of all, we don't want to multiply this binomial 50 times to do the integration. Okay. So we're instead going to let u be x squared plus 1. Our next step is to differentiate. Okay. It says implicitly, I want us to think back to when we did differentials. Okay?
The X and Y.
Huh?
The X and Y.
With like the dx and the dy. Okay? So technically du dx is what? 2x. But remember when we did differentials, we wrote it as du equals 2x dx. Yeah, we can multiply that dx over. That's how I want you to do it here. Okay? So instead of implicitly, I'm going to remind you about differentials.
Would that dx just be the plus c?
Well, we took the derivative, so there's no plus c. Okay? It's only when we take the antiderivative. So du equals 2x dx. Anybody see something kind of nice about it?
There's X and
We have a 2x dx inside of our integral, don't we? So what we can do is we can substitute our u's for x's, which means we also have to substitute our dx for du. But dx doesn't equal du. Du equals 2x dx. So what we're going to do, we're going to change this to the integral of u to the 50th, and then we have 2x dx. That's going to become
du.
du.
Wait, so aren't you substituting the x's for u's then? Not the u's for x's?
U's for x's.
Yeah.
Well,
U's for x.
Yeah, I'm confused, like. Because it's
Okay.
asking you to substitute a u for an x, but you just substitute the x for u.
No, but you define u as x.
so instead of in terms of x, I want it to be in terms of u.
Yeah.
Okay. Would you like me to rewrite my instruction?
Well, no, I'm just like wondering if we're like, is it supposed to be x's for u's?
There we go.
Okay.
Yeah, that's much better. That is much
Okay.
better.
Now we can integrate. Okay. U to the 50th, antiderivative.
1 over 50 u. 1 over 50 u.
You.
Plus c.
C.
What about du?
Okay, so let's talk about what the du means. The du means take the antiderivative with respect to u. Remember that differential tells you what we're taking the integral with respect to. So when we had, like when we had the integral of x dx that said, hey, take the integral with respect to x. since we have u's, this needs to be a du. That just says take the antiderivative with respect to u, which we did. Now, our original problem was in terms of x's, which means your answer should be in terms of x's. So now we need to replace our u with whatever our original function was. That is how we do u substitution.
It just looks like we just raise that to the power and put it outside and then take out the 2x dx.
I don't think we just did the antiderivative. But we could just.
Well, we did.
Why not?
Yeah, we didn't even do all that other stuff.
Yeah, so we could just.
Why did we have to do these?
So,
Okay, well, if we think about taking the derivative here, right, we do the power rule and then we have to do the chain rule. Okay, essentially that's why we have to do u substitution, is because
Because you have the 2x. Yeah.
of that 2x out there.
But you
Okay.
can do it anyways.
You can just do it.
You can just find the derivative of the inside. Right.
Now, I agree with you that there could be a time where you could look at this and say, oh, well, if u is x squared plus 1, I know du is dx is 2, du is 2x dx, and I see that we have it. Some of this, yes, like you'll have the vision to see what's going to happen. But do you think it's quite convenient that I had 2x dx right there? Not all the time is it going to be the exact number that you need. But we'll get to those examples in a little bit. What are you confused about?
Are you just saying very clear?
Okay, so this 2x dx was conveniently right here. It's not always going to be
The
it.
one that isn't.
We'll get there.
Oh, it's the derivative of u, so, okay, now I get it, that's.
Okay, let's do another one.
Yeah, we just drop
That,
that.
is that the same thing one really knows. But we'll do rules.
Okay, so yes, Nathan can see, oh, 3x squared is the derivative of x cubed. That's very convenient. Okay. Now, we have the composition of a function. Well, we have a composition function times another function, which means this is perfect for u substitution. What do we want u to be? Which means du is 3x squared dx. Okay. Conveniently, we have 3x squared dx. So 3x squared dx becomes du, and cosine of x cubed becomes cosine of u.
Oh, I can now.
Okay. Cosine of u du, what is that antiderivative?
Negative, positive.
Wait,
What if you go low?
What over you?
Yeah.
Do we all agree that it's positive?
Yeah.
Okay, how do we check ourselves? The derivative of sine is cosine, so we're all right. Okay, is this how I want you to leave your answer?
Replace it. Just think you.
So it should be the sine of x cubed plus c.
We have to do a little like integrable curve.
Agreeable.
No, because we took the antiderivative, so it's gone.
So does the du already become the constant?
Yeah, agreeable curve.
Well, for this to work, like, there at least has to be the x squared dx. if there's not an x squared dx, we can't do it. Now the 3, we can adjust that, and I'll show you how to do that here in a little bit. But for this to work, you at least, in this case, would have to have the x squared dx. In this case, you would at least have to have the x dx. Okay? So if it doesn't work, you substitute for this. Okay? No.
Yes,
that's-
yes, yes.
What the heck happened?
Oh, magic happened.
It was a yes.
Your turn.
Oh. Slowly. God bless you. And you. No, I got a list of names. What's it called? Those things, like cobras, you know? That's a new life.
Dude, God,
We lost like 43.
what was it? 70? It was like 73 to like 29.
I know, my team's trash. I'm gonna join you guys.
I told you, man.
I will if you want me to.
You can just leave your team for a different team.
Well, the team's garbage.
He played on our team last year, and then he switched teams because he thought they'd be better, and they ended up beating his team anyway.
But like, your
Do your
team
problem, do the
was
problem, please. Do the problem. Do the problem. We're recording, we're live.
Oh, we are?
What? Wait, what? Copy off what?
50 Tyson.
She's just gonna hear like garbage.
Hey, what the 50-hunters?
Oh, I'm rewriting the problem.
Yeah, not necessarily.
I'm already halfway.
He's doing it. Instead of saying copy off what? Call it me. Maybe I should.
There you go, I could have copied it, actually.
People in fifth grade. I'm going to be in fifth grade. But
Is that team? You should cubes or is it?
Jim, I'm trying to focus on
just waiting on your spot. Oh. Is it like that? No, it's not. I think you're doing it on purpose. It's gonna break his nose. I think you got something on the bottom of your right shoe. Careful. You want a face guard. Focus. Focus.
Okay, what do you think of Brady's work?
It's supposed to be the TX or the
Oh,
4.
I see an error.
Next to you.
See an error.
That's good.
For tangent.
No, it's not.
EX tangent and 2x.
Oh,
It's definitely you know.
it's a 4.
That's a U.
That is a
That's a U.
That's a
Well, he
Oh.
meant to write a 4 and it's a little Jewish.
No.
It looks like a and look that down and that's
Questions?
Tangents.
Questions on this? Okay, now let's talk about when maybe it's close. This happens.
Oh.
Okay, that's a good idea.
Is it our turn or is it?
Oh no, this it's our turn. We're doing all these. Okay, So I will leave you.
That's stable.
So you're saying, okay, let's write it to the 1/2. Never a bad idea. Okay, now notice how we have the composition times another function. So u substitution is going to be our friend here. Now, here's the issue. What do you want u to be?
Sub x cubed plus 4. Because why not?
Okay, which means du is what?
There's the do something.
15x
Would it
squared.
be du over 15?
We need to multiply something by
Yeah, so
15.
that it would.
Or divide it.
So there's like an extra 15 thrown in there, right? The constant is not the same that's in our integral. However, we have an x squared and we have a dx,
Oh, so we can just.
right? So we can replace x squared dx
So 5 times du.
with 1/15 du. How did I get 1/15 du? I divided 15 over. Thank you, Chris.
Scribbled out the.
Okay? What? Yeah? Okay. So, whatever you have in your integral, that's basically what you need to isolate out of this differential, and then you can do your substitution. So, since we have x squared dx, I divided that 15 over. So, now we can rewrite our integral. X squared dx gets replaced with 1/15 du. So what I'm going to do is I'm going to put the 1/15 on the outside because it's a constant. We can worry about it later. And then inside we have just u to the 1/2.
That would be great.
So now this is set up nicely for an integration problem, okay? We can keep the 1/15. Let's worry about u to the 1/2. What does the power become? 3/2 multiplied by 2/3 plus c.
Ooh. Yeah, 249.
Whoa, whoa, whoa.
2 what?
Where did you?
Maybe 46.
40 minutes. 47 now.
Sounds good. Oh, yeah, yeah, okay.
Our original problem was x squared times blah 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 to the 1/2 dx. And so since u was this, I just wrote u to the 1/2. Yeah. Okay, so this becomes 2/45 5x cubed plus 4 to the 3/2 plus c. If you do not go back and rewrite your u,
Oh.
you will be done.
How many points? Half? Or full?
Depends. I don't know. One more example, and then I'd like you to work on your homework in class. That way you can get some of these under your belt before I send you on your way. Okay? What?
Whoa, where's the homework slide?
Yeah, that was number 6.
Yeah, I don't know how it got there. I don't know.
Send me a ride.
Because I really enjoy hearing you complain.
You do.
What were you doing so much?
That's why you wanted to teach this class.
Mm-hmm. Okay. Is this a candidate for substitution? Yes. We have a composition times another function. What would we want our u to be?
6x
X to the 6. Which means du is 6x to the 5th dx. Now notice,
Divide by 6.
we have x to the 5th dx. That 6 is extra. So if we want to do the substitution, we're going to have to divide it over. Now, it is not necessary to write this step. I am fine if you do that in your head. However, I do not want you to do the u equals and the du equals in your head. If you're doing a substitution problem, I at least want to see this up here, but I am fine with you doing this in your head. Some of you may need to write this down though, and that is fine. Okay? So our integral becomes 1/6 du, right? Because that's what we're going to replace x to the 5th dx with. And then we have sine of u. Antiderivative of sine.
Negative cosine.
So we have negative 1/6 cosine of, is it x to the 6th? Plus c. How can you check to make sure you did the problem correctly?
In the back of the book.
Okay. In the case of homework, yes, you could look in the back of your book. But if it's like a quiz or test situation, take the derivative. I know the derivative of cosine, negative cosine, would be a positive sine times chain rule, 6x to the 5th. We would get back to the same place. Okay. There is your homework. I am sorry that it was on the wrong slide.